Welcome to the deep dive. Today we're tackling something pretty fascinating in AI.
We are. It's about getting AI to really understand videos.
Yeah, not just see pictures, but grasp events unfolding in space and, time, what experts call spatio-temporal perception.
Exactly. And we're using a specific research paper as our guide here. It's called VideoChat-R1, Enhancing Spatio-Temporal Perception via Reinforcement Fine-Tuning.
Okay.
It really gets into a new and it seems like a very effective way to help AI process the dynamic world of video.
Let's break this down a bit because, AI has gotten really good with text, even still images lately.
Right. Huge strides there.
But the paper points out that getting AI to understand the where and when in a video, that's been a bigger challenge.
It really has. Think about it. It's not just seeing a cat in a picture.
Right.
It's understanding that the cat, say, jumped from the sofa onto the floor and when that happened.
Exactly. A video is like this whole flow of connected moments.
Precisely. So to get it, the AI needs to track things, understand how they interact, pinpoint actions.
When they start, when they stop.
Yeah. It's just a much richer, more complex thing than one static image.
So our mission for this deep dive is to figure out how this new method, they call it reinforcement fine-tuning, RFT.
Using GRPO.
Right, GRPO, Group Relative Policy Optimization, how that helps AI get better at this, like much more precise about timing and tracking objects.
And what really jumps out right from the get-go is how efficient this RFT approach seems to be.
Efficient how?
Well, they found they could seriously boost the video understanding with surprisingly little extra training data.
Oh, interesting.
And this is crucial without messing up the AI's other general abilities.
Yeah.
That efficiency is, well, it's pretty exciting.
Okay, so efficiency is key. Now, to really get how this works, we probably need a little background, right?
Yeah, definitely. This research kind of builds on some recent wins using reinforcement learning, RL, to make the big language models, the LLMs, better thinkers.
You mean models like OpenAI-O1 or DeepSeek-R1?
Exactly those. They used RL techniques, things like adjusting confidence during tests, using rule-based rewards, basically, to boost their logic and problem-solving with text.
And so the next step, logically, was visual information, like images and then video.
Sort of the natural progression, yeah. The focus shifted to applying these RL ideas to multimodal models.
The ones that handle text and images.
Right. And a big focus there became visual reasoning, like, can the AI look at a complex picture and answer questions about it intelligently?
Makes sense.
But, and this is what the paper highlights, using RL for video understanding, especially for that tricky space and time stuff.
Spatio-temporal.
Exactly. Spatio-temporal perception. That's been explored way less. Videos are just, well, they're different, more dynamic challenges.
Okay, so that sets the stage. Now, this GRPO group, Relative Policy Optimization, what exactly is that? How does it help learn video?
So GRPO is a flavor of reinforcement learning, but it works a bit differently. Instead of needing a separate critic model to judge everything,
Which is common in RL. Right?
very common, GRPO, instead, has the AI generate a group of possible answers to a question or task.
Okay, multiple answers.
Yeah. And then it uses its own smarts, its own capabilities, to figure out which answers in that group are better than others.
Ah, so it compares them internally.
Exactly. It compares them relative to each other within that group. The learning signal basically encourages the AI to favor the answers it scores higher itself.
So it's like it's learning to self-critique its own potential outputs.
That's a great way to put it, a kind of self-correction. And really importantly, GRPO has this mechanism built in to stop the AI from drifting too far away from what it already knows.
How does that work?
There's like a penalty term. It discourages big changes from the original model's knowledge base, so it can specialize in video.
Without forgetting everything else.
Precisely.
Mm-hmm.
Which helps maintain its general intelligence. And this more direct comparison, this self-evaluation, seems to be a big part of why it's so data efficient.
Okay, GRPO is the engine. How did they actually, steer it towards understanding videos better? The reinforcement fine-tuning, the RFT part.
Right. That's where designing specific rewards comes in. They basically created tailored rewards to guide the AI, using that GRPO process, to get better at interpreting videos.
And they focused on specific video tasks.
Yeah, 5 common ones to really test and train this. Temporal grounding.
Finding when something happens.
Exactly. Object tracking, following things, then video question answering, captioning, and even video quality assessment.
Let's talk about those rewards. They mention a format reward. What's that about?
The format reward is basically about encouraging the AI to structure its answers clearly. Like maybe output a thinking step first, then the final answer.
Oh, like showing its work.
Kind of. They used specific tags, think for the reasoning, and answer for the final bit. Giving it a better reward for using this format helps it break down the problem.
Makes the reasoning clearer too, I guess.
Yeah, more transparent, and hopefully leads to better answers overall. It's not just the result, but the process.
Okay, that's clever. What about the intersection over union reward, IOU?
Ah, yes, IOU. That was super important for tasks like temporal grounding and object tracking, the when and where tasks.
Right.
It measures how much the AI's prediction, like a time window or box around an object, overlaps with the actual ground truth answer.
So how accurate the prediction is in time or space?
Exactly. The formula they use is IRU, IRU?
Right.
IRU. Basically, the size of the overlap divided by the total area covered by both the prediction, I read, and the truth.
Higher score means better overlap, more precision.
Precisely. So it rewards the AI for being really accurate about when an action happens or where an object is. Think about self-driving cars needing that precision.
Yeah, absolutely critical. Okay, what about simpler tasks, like multiple choice questions about a video?
For those that used a straightforward accuracy reward. Simple binary thing.
Right or wrong?
Yep. Reward of 1 if it picks the correct answer, 0 if it's wrong. Direct feedback.
Makes sense. And the last one was recall reward for captioning. That sounds tricky. Captions can vary a lot.
They really can.
Yeah.
There's often no single perfect caption,
Wow.
so just comparing to one reference isn't ideal.
So what did they do?
They got clever. They used another powerful LLM Quen 2.572b, known for its language skills, to act as a judge.
An AI judge.
Kinda, yeah. This judge model breaks down both the AI's generated caption and the reference caption into key events.
Okay.
Then it checks if the generated caption successfully captures or entails the important events from the reference one. The reward is based on the proportion of events recalled.
So it's rewarding completeness, capturing the essence.
Exactly. A more nuanced way to judge something subjective like a caption.
Okay, so using GRPO plus these tailored rewards, that's how they built this new model, VideoChat-R1.
That's the recipe, yes. Applying GRPO with these video-centric rewards, training across those different spatio-temporal tasks that resulted in VideoChat-R1.
And the big headline, what did it achieve?
Well, the main achievement is hitting state-of-the-art performance on understanding the where and when in videos, that spatio-temporal stuff.
Without sacrificing its other skills.
Exactly. It kept its general conversational abilities, which is often a worry when you specialize a model, and they even saw some early hints of improved spatio-temporal reasoning.
That's impressive. Can you give us a feel for the numbers? How much better did it get?
Oh, the numbers are quite striking. Compared to a strong baseline, Quen 2.5 VL7B VideoChat-R1 showed, well, massive gains in those specific spatio-temporal tasks,
Right.
like plus 31.8 percentage points for temporal grounding and plus 31.2 for object tracking. Huge jumps.
Wow. Okay.
And it also nudged up performance on broader video benchmarks too. Video ME, MV bench, perception test by a beta point each. So specific improvements and general ones too.
And you mentioned the data efficiency earlier. That still holds true for these results.
Absolutely. They achieved all this using a data set of only around 18,000 examples.
That's really not much in the grand scheme of AI training data.
It's remarkably small, especially for video tasks. It covered just 3 areas: temporal grounding, object tracking, and grounding QA. It really highlights how effective this RFT approach can be.
Which is great news, right? Means maybe you don't need these colossal data sets all the time.
Exactly. It could make this kind of advanced video understanding more accessible.
So digging into the experiments, what were some other key takeaways or findings?
Well, that data efficiency of RFT was definitely a major one. How it improves specific tasks without causing that catastrophic forgetting of general skills.
Yeah.
That's a big win over typical supervised fine-tuning.
Which often needs way more data, right?
Way more, yeah.
Yeah.
Another finding was that training on multiple spatio-temporal tasks together actually boosted overall performance.
Ah, like a synergy effect. Learning one helps the others.
Seems like it, yeah. That joint training was beneficial.
Interesting. What about that thinking step with the think tags? Did that always help?
That was actually a bit surprising. It turned out that making the model explicitly output its reasoning didn't consistently improve performance on the more straightforward spatio-temporal tasks, like the grounding and tracking.
Really? Why do you think that is?
It's hard to say for sure. Maybe for those tasks, the direct perception is more important than elaborate reasoning steps. But it did seem to help for more complex things, like the video question answering.
Okay, so it depends on the task complexity.
Seems that way. And another clear finding was just how well GRPO itself performed compared to standard supervised fine-tuning, SFT.
How so?
GRPO consistently came out ahead. Better scores on the specific tasks, better on the general benchmarks, and it was less likely to overfit the training data even when trained for longer. Like it learned a more robust understanding.
Learning to judge its own work paid off.
It really looked that way.
The paper apparently had some figures, figure 2, figure 3, showing examples. Can you maybe describe one or two? Help us visualize what VideoChat-R1 can do now.
Sure. Figure 2 had great examples of temporal grounding. You see VideoChat-R1 pinpointing actions really accurately. Like one was person puts on a pair of shoes.
Okay.
The ground truth time was like 1.8 to 9.4 seconds. VideoChat-R1 predicted 2.0 to 10.7, very close, and even gave its reasoning. Person bends down, picks up shoes, puts them on.
And it generated that reasoning itself.
Yeah, within those think tags. Another example, person puts it back on the table. Ground truth 25.7 to 32.0 seconds. Prediction 26.9 to 32.0. Again, very tight alignment.
That's quite precise timing. And figure 3, that was video QA.
Right. It showed how VideoChat-R1 could answer questions and point to the evidence in the video. Like one question, what does the driver do after letting go of the steering wheel?
Okay.
The answer was beat. VideoChat-R1 got it right and identified the time segment, 3.8s, 17.9s, explaining the driver's movements.
So it links the answer back to the specific moments in the video.
Exactly. Another one, why did the girl suddenly jump up? Answer was E, excited. VideoChat-R1 picked E, gave the time 20.1s, 28.0s, and linked it to her playing with a toy rocket. It's connecting the what with the when and why.
Okay, so wrapping this up, what's the big picture message from this deep dive into VideoChat-R1 and RFT?
I think the core takeaway is that reinforcement learning, especially this RFT with GRPO approach, is proving to be a really potent and maybe more importantly, efficient tool for boosting AI's grasp of video.
Especially that crucial spatio-temporal understanding, the where and when.
Exactly. Getting that right is key to truly understanding video content.
And the data efficiency point keeps coming up. That seems really significant for actually using this stuff.
It absolutely is. It potentially lowers the barrier to entry for developing sophisticated video analysis AI. Makes it more practical.
Looking forward then, what kind of real-world impact could this have? Where might we see this kind of improved video understanding show up?
Oh, the possibilities are pretty broad. You could see much smarter surveillance systems, safer autonomous vehicles that perceive their environment better,
Makes sense.
much deeper analysis of media content for creators or researchers, maybe even more intuitive ways for us to interact with video data through computers. It touches a lot of areas.
Okay, that paints a compelling picture. So let's leave our listeners with a final thought to chew on.
How are you?
Now that AI is getting so much better at grasping the when and where in videos, what totally new questions could we start asking it? How might this change how you interact with video, how we analyze the absolute flood of video data out there?
Yeah, what does it really mean for an AI to have a solid spatio-temporal intuition about the visual world?
Something to think about. It's definitely an exciting space to watch. Thanks for joining us for this deep dive.
Thanks for having me.